All right, welcome back to ABA exam review and the continuation of our RBT practice questions series, where we're going through the next set of questions together and breaking them down. If you're new to the channel, welcome. If you're returning, welcome back. Please like and subscribe. Check out btexamreview.com for all of our study materials, including our combo pack and practice exams. When you pass, let us know so we can include you in the Sunday shout out. Work hard, study hard, spread the word. Let's get going. Your client is motivated by coins, so your supervising behavior analyst brings a bag of nickels that your client can earn during DTT. Client keeps their coins in a pile next to them. If the client puts their head on the desk to escape work, the client loses a coin. What type of intervention involves losing the coin if you want to decrease head on desk behavior? What do we know about this question? First, let's see, what is the question asking? The question is asking about the type of intervention that involves losing the coin, and importantly, if you want to decrease head on desk behavior. So sometimes we're going to know how our consequences affect future behavior, and that's going to tell us what type of consequence it is. Sometimes we won't know how it affects future behavior. But if we have our goal, which is to decrease head on desk behavior, then we're trying to punish that behavior. So it's two different ways to look at the consequence. We don't know how it's going to affect the client, but we do know what we're trying to do, which is decrease head on desk behavior. So how are we going to do that? Well, we're going to take away the coin. We know the client is motivated by coins, so the client earns coins during DTT. They're basically tokens of sorts. The client keeps the coins in a pile next to them, but if they engage in head on desk to escape work, they lose the coin. So if the client engages in the target behavior, we take the coin away in order to punish that behavior. What is this called? A, negative reinforcement. It is negative. We're taking something away, but we're not trying to reinforce this, right? We're not trying to reinforce the behavior. We want to decrease the behavior. And since we're trying to decrease it and we don't know what future behavior is doing, we're trying to punish that behavior. So A is out. What about B, positive punishment? Well, it is punishment, or we're trying to use a punishment intervention, but it isn't positive. Why? Well, the consequence is taking the coin away. We're removing the coin. And when you remove something, negative. Now, what is C? Response cost. So response cost is a specific type of intervention that involves taking away or removing a reinforcer contingent on a behavior occurring, which is exactly what's happening here. The response cost here is you put your head on the desk to escape work, I take a coin. So the response cost is also known as a negative punishment procedure. So the type of intervention we're using here is C, response cost. If we had negative punishment, that would also be correct. But the specific intervention where you take away a reinforcer contingent on a behavior occurring is C, response cost. Marshawn wants his son to do a jumping jack, but his son is refusing. Marshawn says, "What is your name?" And then, "How old are you?" And then Marshawn says, "Do a jumping jack." What is Marshawn attempting? What do we know? We know the question is asking about Marshawn's behavior. What is Marshawn doing? Well, he wants his son to do a jumping jack, but the son does not want to. So Marshawn says, "What is your name?" And then, "How old are you?" And then he says, "Do a jumping jack." It's the only information we have. We have to go by the information that they give us. Now, do we know if Marshawn's son can say his name or say how old he is? We don't. We just know that's what Marshawn is asking, followed by do a jumping jack. But if you had to pick one intervention and to describe what this looks like, what intervention would you pick? A low probability request sequence. We don't call it a low probability request sequence. We call it B, a high probability request sequence. And why is that? Well, because the sequence involves some high probability request followed by the low probability request. In this case, it looks like Marshawn is asking the son to say his name and to say how old he is. And then he follows it with the low probability request of doing the jumping jack. So it looks very similar to a high probability request sequence. Let's look at all of our answer choices. Always read every single answer choice. C, non-contingent reinforcement. Do we know what the reinforcement is here? Do we discuss reinforcement? We don't. We don't know what the reinforcement is. Marshawn isn't reinforcing the son on a schedule. Non-contingent reinforcement doesn't really fit. And what about D, shaping? So be careful here because Marshawn is asking his son to do different responses, but they're all different behaviors. We're not shaping up anything. We're not looking at the jumping jack specifically and shaping up approximations. He's simply asking him to do different requests and then following it with the lowest probability request. So we're not reinforcing approximations here. We're not talking reinforcement, so C and D are out. So therefore, it has to be B because there's no such thing as a low probability request sequence when you give a bunch of requests that are high probability, followed by the low probability request. That's a high P sequence or a high probability request sequence. Following data was gathered while observing a new client. X indicates a response occurred, while 0 indicates a response did not occur. What is the percentage of occurrence based on this data? And then we have data points. Now, don't panic because you have to interpret the data. Very, very straightforward. That's the great thing about most of the data we take is that the data we take are typically pretty easy to interpret. The most important thing you want to know is what are you trying to figure out? What are you trying to measure? Well, here we're measuring percentage of occurrence, which simply says how or what is the percentage that something happened based on the amount of possible occurrences. So let's find out how many occurrences first. Well, we have 1, 2, 3, 4, 5, 6, 7, 8. 8 possible occurrences. So what do we know? We know that X indicates a response occurred, while 0 indicates a response did not occur. So simply, we need to find out how many occurrences were there given the total number. And X is going to tell us that. We have 1, 2, 3, 4. We have 4 occurrences out of a possible 8, which gives us what percentage? Well, we divide 4 by 8, multiply by 100. That's going to give us 50. This is really simply a percentage question. And so if you know how to do percentages, this question should be super, super simple for you. Remember, you have to know how to do an average, a simple percentage, and a total on your exam. That just requires a little bit of practice if you don't know how to do it. Most of you already will. And so when you get an average question or a percentage question or total question, it's going to be very simple. Here, you're just looking at, okay, I have X, which is my occurrence. I have 4 occurrences out of a possible 8. That's an easy way to say the percentage of occurrence was 50%. Don't overcomplicate it just because we have some data points. The data points actually makes it easier. You have to flip how you view these type of questions. Taylor's older brother tells Taylor that he should wait at least 3 days before calling a girl after he goes on a date with her. Taylor's brother's recommendation of 3 days is most like blank relative to the end of the date. All right, kind of a tricky question here. Let's slow down and try to understand what we're looking for here. We have Taylor's brother's recommendation of 3 days. 3 days relative to what? Relative to the end of the date. So what does Taylor's older brother tell him? He tells Taylor to wait 3 days before calling the girl after he goes on the date with her. So that 3 days, first off, represents an amount of time. So our measurement has to do with time. Think about what measurements we use time with. The main ones are latency, interresponse time, and duration. Rate also has time, right? But we need frequency as well. We need frequency over time. This is not a frequency over time situation. We're not looking for a rate here. We just have one length of time, 3 days. Now, 3 days relative to the end of the date. So our entire sequence is the date ends, Taylor waits 3 days, and then he calls the girl. So we're looking at the time in between the end of that date and Taylor calling the girl. In other words, the time between the SD and the response. So when we have the time in between the SD and the response, what do we call that? Well, we call that A, latency. Why is it not inter-response time? Inter-response time is time in between responses. We're not looking for time in between calls. We're looking for the time that date ends, where Taylor makes the first call. It's our latency. It's not frequency. Okay, we're not counting the number of calls. We're looking at the 3 days relative to the end of the date. And so if we had just said Taylor's recommendation of 3 days is what? Well, then it's ambiguous because then we could have said, well, we're counting the number of days, right? Or we could say duration. So that makes it a little ambiguous or unclear. However, when we talk about 3 days relative to the end of the date, it's relating back to the end of the date. And so relative to the end of the date, that 3 days is representing the latency between the date ending and Taylor making the call. You've got to be very precise here. This is not the easiest measurement question. You've got to read all the information they give you and really understand what they're asking. Same thing with rate. We're not looking for frequency over time here. We're not looking for rate. What we're looking for is our latency. The date ends, 3 days pass, first call happens. Time between the SD, end of the date, to the response to the call, 3 days. That's our latency. 2 years ago, Dan forgot to save his Word document and he lost everything when his computer crashed. Now, when Dan is writing in Word, Dan saves every 10 minutes, which prevents him from losing all his work if his computer crashes. What type of consequence is occurring? So we have a consequence question. So let's start by asking ourselves, how did Dan's behavior change? Well, we know 2 years ago, Dan forgot to save his document. He lost everything. Not good. Now, when he's writing in Word, he saves every 10 minutes. And now he doesn't lose all his work if his computer crashes. So he used to not save. Now he saves. His behavior has increased. His behavior has been reinforced. Why is his behavior being reinforced? Well, saving prevents him from losing all the work if his computer crashes. Dan is preventing that outcome or escaping the outcome or avoiding the outcome, depending on how you want to look at it. And so when we prevent, escape, avoid, and our behavior increases, that's going to be negative reinforcement because his behavior is increasing. His behavior was reinforced, his saving behavior, and he's escaping something. So he's removing the threat of losing all of the work if the computer crashes, making it negative. It can't be C and D. His behavior wasn't punished. Okay, we're looking at saving the Word document, which he does now. Whenever he's writing, he saves all the time. So his behavior did not decrease. It increased. It increased. It was reinforced. He escaped or avoided or removed the threat of losing the work if his computer crashed, making this be negative reinforcement. Another tough question. 2 tough questions in a row. So here's where, if you've missed one or both of these questions, you stop, go back, review. The whole point of doing the questions is active reviewing. When you miss a question, you don't go to the next question. You review that question until you understand every single one of these terms and why the right answer is right and why the wrong answer is wrong. That's how you get better at ABA and the exam. Tokens can be used for or are considered which of the following types of reinforcement. Great. This is how it might go on test day. You might get hard questions and then a couple easy questions. We can't let our progress and our momentum and our emotions get affected by the difficulty or the perceived difficulty of the questions. All you can do is answer what's in front of you. So we have tokens, which can be used for or are considered, so 2 different things. What types of reinforcement? A, positive. Can tokens be used for positive reinforcement? Absolutely. B, secondary. Are tokens secondary or primary? Well, primary is unconditioned, secondary is conditioned. Tokens are conditioned or secondary. And can tokens be generalized condition reinforcers? Absolutely. You can use them in a variety of situations. So tokens can be positive, be secondary, and they can be generalized conditions. So tokens can be D, all the above. Thank you for watching. Check out btexamreview.com for all of our study materials. Please subscribe if you have not already. When you pass, let us know. Work hard, study hard, spread the word. We'll see you soon.